the remainder theorem. If r is the remainder after dividing the polynomial p of x by x minus r, then p of r will equal r. Let's kind of look at that a little slower. So if r, capital R, is the remainder, it'd be a number, that is the remainder after dividing the polynomial p of x by x minus r, then p of r, in other words, you put the little r into the function itself, it's going to equal r, the remainder. The remainder theorem states a simple but surprising result. Let's look at an example to understand what it's really saying. Example. First, we will do the division below to find the remainder. So we're taking x cubed minus 2x squared plus 5x minus 12 and dividing it by x plus 3. So when we divide that out, whatever method you use, the long division method or synthetic division, we get x squared minus 5x plus 20 minus 72 over x plus 3. So the remainder is a negative 72. Negative 72. Second, we will let x equal a negative 3 and evaluate p of a negative 3. So now we're taking that little r, which has to be a negative, because if you notice in the remainder theorem that was x minus r, so it would be x minus a minus 3 would be the x plus 3 we have in this particular case. And now we're going to put that negative 3 into the function. F of a negative 3, we evaluate that, and what do we get? A negative 72. Note, these are the same. So the remainder is the same as if we put the little r, the negative 3, into the function. We're going to get the remainder. This is going to be a helpful property, since this always works. Summarizing the results of the above calculations as it relates to the remainder theorem. Since we are dividing by an x plus 3, and the theorem divides by x minus r, the r in this problem is a negative 3. So according to the theorem, we can find the remainder that results from dividing x cubed minus 2x squared plus 5x minus 12 by x minus 3 by putting the negative 3 into the function. In other words, f of a negative 3 equals a negative 2, 72. This is kind of an outstanding result, and a surprising result to me.